Okay, so again, I try to at least give you some time in class each day, especially when I just assigned something yesterday. Did everyone receive an email from me this morning saying that you have homework due tomorrow? I think I sent it out like really early this morning. Just to kind of remind you. Okay. If you haven't already, or if you haven't checked your email, I did send you out that. I'll try to do my best of doing that the day before homework's due. Like, just to kind of remind you, gentle reminder in the morning, like, hey, homework's due tomorrow. Some people just don't check that type of stuff, but it's good practice. Keep that in mind. Let's see, we are out of here at 10:14, so it kind of gives you an idea. We've got about 30 minutes or so. All right, on the board, if you can see that, I don't know if you guys can see that from over there, we're doing exponents today. It was something that I even heard some of you ask yesterday, like, were you going to cover exponents? I don't really remember how to do that type of stuff. Well, yeah, it's part of the second section. I was just kind of waiting to kind of see where you're at. So we're doing exponents, we're going to do expressions today, kind of a similar situation we did yesterday. We really talked about algebraic expressions with like numbers and variables. Now we're going to be adding powers to them, right? The exponent. We're going to look at laws of exponents that you've seen in Algebra 2. To refresh your memory and like the basics with that. We're going to look at vocab terms. So if I start using a lot of vocabulary, you know kind of what I'm talking about. And then the goal today is maybe do a couple times like order of operation kind of an idea. That's kind of the idea. I'm not going to go too far in depth. We're going to continue on with this topic tomorrow. But we're going to get the basics today, if that makes sense to you. Got it? Okay. If you have a calculator, it might be actually a good thing to have that out. If you want to go borrow one, go by all means. Remember, I only have 10. Hopefully there's all 10 back there if you want to double check.
I have one in my car, I just never remember to bring it in. Hey, Ward.
What's up?
What I do like is when I divide stuff on here, it always pops out as a fraction instead of
I'll take a look at it.
Well, I know, I get online. I want to do
So yeah, so hey, the reason why I want you to like have your calculator out.
You got all 10, by the way.
Alright, the reason I want you to have your calculator out or borrow one from me is that way you get some practice, like where's that button even located? Because like if you just got a new one, or you just kind of don't remember, like I can show you kind of where those buttons are. It's kind of nice to know that. That way when you get to your homework, you're not completely lost. I know you can type stuff in Google, but that's just not proficient. So, alright, let's kind of walk through some of this stuff. I want to talk about the actual exponents stuff.
Have you seen that calculator where it's like a T81 something or other, and you can get like games on it?
Yeah, I have games on mine.
Oh, yes.
That's dope.
Bro, it'd show that.
They're the dumbest games ever. Like, you can go buy like a little Game Boy from like Target for cheaper than that thing.
Okay.
So.
No, you can like download like Pac-Man.
Yeah, and you can type it in yourself.
Did you
can
do that?
program. Yeah, I did a screensaver like stupid fish. It's dumb. It's just,
Let me
I
see.
tried it all. Trust me. All right. Okay. So here's the first idea. So let's talk about the example of like what an exponent is, right? So bless you, whoever's. All right. So here's what we got. This is just kind of a random example to get us used to the vocab terms. Okay, so what we have here, this is an item that is in what we call exponential form, right? There is an exponent to this problem. It looks like a traditional algebraic expression. It's got numbers, letters, combined with basic operations. Add, subtract, multiply, divide, parentheses and exponents kind of a thing. So the basic terminology. Anything that has a power on it. Like on this problem, only the x has the power. How I know that? There's no parenthesis around the 5 as well. If they wanted the 5 to have the power on it, they would do something like this. That's how I know it's just on the x itself. They don't have the parenthesis around. So the item that has the power, that is called the base. Now in our case it is a variable, but a base has a power. It could be a number that's a base, a numerical base, as opposed to an algebraic. The actual item in the power itself is a power or exponent. And the item out front, and this only works if it's an algebraic expression where there's a variable. The item in front of the variable, that is called a leading coefficient. That only works if you actually have, a base as a variable. Because otherwise it would just be a constant, right? So, because you can have numerical stuff. You can have something like this. That would just come down to a number. It's a constant, it's a digit. But yeah, so you can have a base, but typically if it's a leading coefficient, base was probably a variable. Okay, Questions with the vocab terms if I start using those, you kind of know what I'm talking about. Okay, so now that we have the basic vocabs, we know what an exponent looks like. The goal is to really talk about, number one, how do we even type in the calculator? So let's start with that 7 to the third power idea. Then we'll come back and we're going to start looking at stuff like this where we start doing the laws of exponents. Like when we start putting powers on other things other than just one letter. Like what do we do if we have to add, subtract, multiply, or divide? That type of thing. Okay, so let's start with that 7 to the third idea. This is 7 to the third power, or 7 cubed, if you will. Cubed means power of 3, because cubed is in 3 dimensions. That's just how I always think of it. But how are you supposed to type this in? Now, most calculators in here, from what I can see, you have a little caret key, little up arrow. It's usually off to the right. It's above the division key or multiplication key, somewhere in that ballpark, correct? It's off to the right. You hit the little caret key, that's what I call it, and then you type in the 3 and hit enter, and it should give you a number like 343 or something stupid. Is that right?
Yeah.
Okay. Now, if you don't have the little caret key, you probably either have like a Y to the X key or an X to the Y key. Even some Casios might even have like a block with another block kind of a thing. I have no idea. There's a ton of different keys that they have. You're going to hit that button. It's basically typed in the same way. 7, hit a little XY key, type in the 3, fine. On a Casio, if this is what they're showing, maybe in some text instruments, I think you have to hit this button first. It gives you the 2 boxes, then you can go like use your arrows to go fill them in. Is anyone struggling to get the 300 number, 343? Is everyone getting that? Because I know, like, if you're in like chemistry or you're in some of those science courses, they do have you change your menus on your calculators, and then everything's messed up, and you can't get normal numbers coming out of that thing ever. So, are we good? Everyone's got the number? Okay. So that's the next one. Now, what this actually means, because a lot of people don't know. I mean, they know how to get the number, but they don't actually know what it's telling you. 7 to the third power literally means 7 times itself 3 times. Right? That's what it means. That's all an exponent is. It's a shorthand for writing multiple numbers being multiplied together. It's always multiplication. That's just how it works. So on this particular problem over here, when we had 5 to the x squared is power of 2, it is literally telling me this. That's all it's saying when I see that. So it's 5 times some unknown number times the same unknown number. That's all it's saying. All right, questions with the basics, like super basic. Super basic. Okay, let's jump in and let's talk about the other things now. All right. First things first. We're going to get these laws of exponents. This idea of like, how do you add, subtract, multiply, and divide exponents? Things with exponents. So, first example. 7x squared plus x to the third plus 5x squared. Do you agree we have an algebraic expression? Numbers, letters combined with basic operations. And can you guys see that over there, or is there a nasty glare? You can see it? Okay, all right. Whenever you have an algebra problem where there's adding and subtracting, the only thing you can add and subtract are things of like terms. In a stupid way of saying is like if you're adding, baseballs and soccer balls, they're not really the same idea. I know it's a sport-related object, but if you want to know how many total soccer balls you have, you don't add baseball numbers to it, right? You just add the soccer balls by themselves. Well, that's what you have here, right? These are the same item, right? They have the same label. That's a soccer ball versus a baseball, right? So you can only add the like terms together. So how many total soccer balls do I have here?
12.
12, right? You have 7 and 5, that makes a total of 12. If that makes sense. I mean, that's the dumbest way to put it, but just some people need to see that because they get so used to just blitzing through like, oh, 7 plus 4 plus 5. I don't care that they had all x's. They have to have the same power because the power makes a new label. That's the idea. Now, I don't care the order you put it. The book is really finicky about when you add these up, you simplify. They want it in what they call descending order, right? The biggest powers of x's are first, then it goes the next biggest power of x until you don't have any left. these are the same thing. What's the difference? I don't really see the difference. I understand there's a purpose for putting it into this form later, but for right now, I don't care which one you pick. So, questions at all about, adding? Subtracting is the same idea. So if I want to put a subtraction symbol here instead, now we're just down to 2. Same idea. All right. Questions at all about adding and subtracting? Those are the easy stuff. You can just add like terms. Even if they have different variables, you can't do it anymore. So if they added a y here, after the x squared, now you can't add anymore. So now you have 7, and you still have that minus 5x squared. Like, you couldn't do anything here. The reason why is that one had a y, that one didn't. You can't add them anymore. Okay, I think I've beat that one enough. Let's move on to the next part. Let's talk about these exponents, these laws. The laws of exponents you learned in Algebra 2, it's usually, first chapter or two, when they start teaching you how to do exponents and stuff. It's basically just how do you multiply and how do you divide. That's really what it comes down to. Because most people don't figure out how to add and subtract, but it's the whole multiplying idea. Like 4x squared y times 3x y to the 7, right? Now I don't know if they have a dot, sometimes they just use the parenthesis idea, it's the same thing, they're all being multiplied together. The trick is, what are the numbers you actually know that are up there?
4 and 3.
4 and 3. That's really the only thing you know. That's the only thing you can multiply. So 4 times 3, that's 12, right? Everything else, you don't know it, so really you're not supposed to do anything with it. So you're just supposed to put them in the bag. Like that. Because I don't actually know what those are. They're all being multiplied. You just don't know what they are. That's the whole concept with multiplying. Like if you know the numbers, do it, but if you don't, just tack them in the back. Because if you go back to that definition of an exponent I showed you earlier, it's just everything multiplied together. Well, that's what you have here. You have 12, you have a couple x's, you have a y, you have an x, and then you have a bunch of y's back here.
Alright.
So that's literally what it is. And that's why when you get down to your final answer, that they'll just say it's 12, and then according to that property in geometry that we've had, which is called commutative, commutative means you move things around, right? It doesn't matter the order you add, it's still the same answer. It doesn't matter the order you multiply things, it's still the same answer. It only works for multiplying and adding. That's why they can move all the x's to the front. Right? They can move all those x's up, because it doesn't actually matter where you put them. And then all the y's you can put in the back. Alright, that's easier, you guys get the idea, right? And so that's why the total in the end is that you have 3 x's and you have 8 y's. Because you can just rearrange them all and then they just go back together using that definition of an exponent. Does that make sense, the real concept of what you're doing there? Because sometimes in Algebra 2, they teach you all these stupid rules. They're like, oh, anytime you multiply, you have to add powers. And then people are like, I don't know if I'm supposed to add or multiply them together, I have no idea. What is it telling you? What are you doing? Well, this is what you're really doing, so you don't have to think about the stupid rule. I'm just multiplying numbers, and everything else is in the back. Well, I can't do anything with the things in the back. Some people just always get lost in this. They're never taught that. They're just always taught the stupid rules. Remember the rule, and then there's so many stupid rules, you can't keep them apart from each other anymore. All right, questions on the concept. Okay, that's the, what do they call it? That's the product rule, if you want a rule to it. It's a product rule, that's how you multiply things together. You're supposed to add the powers, but this is the real process of what you're actually doing. So if you just want to go from here down to the bottom, because you can remember that, just do that. I just wanted to show you this, why did they ever come up with this in the first place? This is what they're doing. Okay, now, let's talk about the next part. Let's go a little bit more challenging. I'm going to go to that one that I wrote up here on the board earlier. something like that. This is that second law of exponent, right? It's power rule. Okay, that's what they call it. You're putting something to a power, right? And the rule that they teach you is that you're supposed to take the 2 and put it into the parenthesis on both items, whatever's in there. So if you have like 9 different items in there, everything gets the 2. So the 5 will get the 2, the x will get the 2, everything. If there's other things in there that have powers, I'll do that here in a second. But this is what you're supposed to be doing. So everything gets 2, so this is 5 squared, which is 25, and that's an x squared, like that's your answer. Now, the number one thing people struggle with is like, okay, why? Like, why did it get to that point? Why did the 5 get it? Like, why did it turn out to be a 25 and not a 10? That type of thing. It's because it's based on this rule over here. They just never tell you that. That's literally what it stands for. That you're actually just taking the 2 parentheses, right? And you're actually just writing out what that exponent means. It means you have 2 of the bases being multiplied together. Because that's what an exponent, right? It means that you have 2 of those bases. It's like when I wrote this earlier, when I had x squared, you had 2 of the bases, like separated. Well, the base was a 5 and an x. So I just had 2 of them. And so when you multiply these, you can just rearrange. And that's why it turns out to be this stupid answer. That's the whole concept behind it. All right, questions at all about the process here? Okay, now, last thing I want to talk about. How do we deal when there's powers on powers? So somebody give me some powers.
2.
2 and I heard 4. I'm going with So last concept today, and then I'll give you some time if you want to work on your homework. Okay, we have y to the second to the 4th power, right?
Multiply.
Yeah, this is the rule where they teach you the shortcut. Just multiply the power, right? You take the 2 times the 4, you multiply these together, and so you get y to the 8th power, right? Now some people are like, okay, yeah, I remember that, And some people are like, I didn't know that. Like, this was a struggle enough, but why? Why did it turn out to be 8 or y to the 8th power? What was the real math behind it?
I don't know.
You take the parentheses for it.
Yeah, exactly right. You have whatever's in the parentheses, and you have 4 of them. Like, that's the real math. That's why they taught you that shortcut back now for 2 days, right? That you have 4 of those y squares. So then if I take the y squares and I break them down even further, where you'll literally have 8y sitting there. And then it comes down to this. Does that make more sense now? The concept of like why these things work sometimes? Some people you never get that stuff. They just don't teach you that. They just teach you the shortcuts and you never get why did it actually work out in the first place. Okay, that's enough of me talking at you today. I want to give you a little bit of time if you want to finish up that assignment from yesterday. So you got about 10 minutes or so. I do want to give you time where you can work on it and ask questions. Homework due tomorrow. Now if you already finished, done, complete, however you want to say it, you can turn front basket, back basket. I'm totally fine with that. I know some of you have already done that. Some of you turned in yesterday. I'm going to get those back to you tomorrow. That's one of our first assignments. I would expect an assignment tomorrow, just because we're going to be at that last part of the section. We don't always get homework on the same days in the week. We just don't. It just happens to be the first week of school. I would expect a very similar type of assignment, something shorter. I consider shorter, just because there's not really much we can do. We still have a lot of notes we have to take here. We haven't talked about division. We haven't talked about scientific notation, like why did they ever come up with this stuff in the first place anyway. So that's what we're going to do. Okay, but I'm done.
I'm done good, but
10 minutes.
I go get mine out of the book, please.
I'll give you that.
Is most of that homework gonna be due the day after or the day?
2, 3, some days, like I hardly ever do.
Ryan, we're gonna do analyze.
Why it's always there.
Oh,
Yeah,
go
there.
there.
From going
Got it.
from geometry
You know what that
and
is?
having to
That's one we're gonna
use it
cycle
and then
through.
just be
Cycle
like,
through,
oh, it's
yeah.
tomorrow. It's like-
30 days on, there you go.
Things are getting prophetic skills.
Oh, sure,
Before we
that
get
is
into it,
calculator,
it's
right?
will be
Yeah,
lots
that's
of
like
like,
calculator.
Oh, yeah.
so
Well,
it will eventually
yeah,
grow.
you just have to scale the equation and scan the QR code.